everyone, welcome to this new episode of the Industry Shakers. My name is Adlane Fellah. I'm the Chief Analyst at Maravedis Research, and it's my pleasure today to welcome Robert Stacey, who is the 2.11 Working Group Chair and the Senior Principal Engineer at Intel. Hello, Robert. How are you today?
I'm great. Thank you. How are you doing, Adlane?
I'm excellent. Thank you. Before we move to the questions, people, please like, subscribe to the channel. So it helps us get going with this. I want to also thank the sponsor for this episode, which is YBuzz, the single pane of glass platform for managed Wi-Fi. So the first question to you, Robert, is what are the top programs the 802.11 working group that it's currently working on? And you can share a slide here.
Okay, yeah, I'll bring up my slide. Okay, so this slide shows the programs that we currently have in flight in 802.11. In 802.11, we initiate programs in what's called Wireless Next Generation Standing Committee, WNG on the left there. In 802.11, these are the current activities that we have going on in 802.11. Activities are initiated in what we call the Wireless Next Generation Standing Committee. So that's through individual presentations that are made there. Coming out of that committee, we can start either what's called a topic interest group or a study group. A topic interest group will write a report, and we currently have one topic interest group, which is the automotive TIG. There's a study group would write a project authorization request, and we currently have one study group writing a request on post-quantum cryptography. A study group, if the PAR is approved, would form a task group. And we currently have 5 of those without an approved draft. We have BN, which is the popular one at the moment. That's the basis for Wi-Fi, expected to be the basis for Wi-Fi 8. And then there are a number of others. There's BR, which is enhanced light communication, BP, which is ambient power communication, BQ, which is the integrated millimeter wave group. And then we always have a revision project in flight. RevMF is our current project. And that is rolling. That group rolls in amendments and produces a new revision of the standard. We have one task group, BI, which is looking at enhancing privacy. They have an initial draft. They're currently in working group ballot. And then we have some projects that are nearing completion or have completed. So BK, which is enhancing the ranging protocol in 11 for indoor positioning, adding 320 megahertz channels. And then there's BF, which is the wireless LAN sensing project. Both of those are ready for approval. They haven't been approved yet, but they are ready for approval. And then we have 2 groups that have published, recently being published. That's BH, which was a group looking at random and changing MAC addresses, solutions for that problem. And BE, which is, you'll be familiar with, that's Wi-Fi 7.
Right.
And then our current published standard is the 2024 revision of the standard.
Wow, it's a lot of programs you guys are certainly working on. So thanks for providing that great overview. Now most people are interested in the basis for Wi-Fi 8, which is the 802.11 BN amendment. So tell us where we are there and what to expect.
Okay, so BN, which is expected to be the basis for Wi-Fi 8, it may not be the only basis. I mean, Wi-Fi 8 may include some of the security work that's also going on, but let's focus on BN. So BN, we just had our May session, and we're getting close to an initial draft for BN. So an initial draft that will move us into working group ballot. We usually label that a 1.0 draft. So we didn't make it in the May session, but we expect it to come out of the July session. So coming out of the July session, we should have a 1.0 for BN. Now, BN is focused on reliability. So if you recall, Wi-Fi 7 was focused on multi-link support. And so in terms of reliability, what we're looking at there are changes related to bounding the maximum latency for real-time applications. So, trying to bound the maximum latency that packets experience on Wi-Fi, to reduce the jitter and provide better support for latency-sensitive applications, VR, AR, voice, video, that kind of thing. There's also some changes related to roaming to improve the roaming, indoor roaming. So when you move from one access point to the other access point within a building, so better support for the handoff between those access points, reduce the latency, the switchover time there. There are further reliability enhancements at the PHY level. There are some enhancements to the coding. And then there's something called, there's an attempt to extend the range as well, provide a waveform, a PPD format that could close the link between the access point and remote clients, for example, video cameras in a home, things like that. So that's the sort of, there's some efficiency enhancements related to multi-channel operations when you have a wide network, a BSS that has a wide bandwidth, but you have a lot of clients that are narrow bandwidth. So there's some efficiency enhancements related to that as well.
Okay.
Hi there, Magnus Johansson, CEO at Wibus. Thanks again for joining us for another fascinating conversation. For the past 10 years, we've quietly powered managed Wi-Fi solutions for 10 of America's biggest telcos. If you use branded Wi-Fi from AT&T, Frontier, or Optimum, chances are you experienced our tech already. Now we're stepping out from behind the scenes, bringing this proven platform directly to MSPs like you. If vendor lock-in, rigid roadmaps, rising costs, and growing complexity are holding your MSP hostage, you're not alone. 72% of MSP CEOs are right there with you. Here is your way out. YBIP OS, our open source vendor agnostic OS built specifically for MSPs. Think of it as your Android moment, restoring your strategic control and agility. One intuitive dashboard to manage your tech stack? Done. Legacy enterprise Wi-Fi running seamlessly alongside next generation open Wi-Fi? Absolutely. Reduce your R&D costs by at least 30%? Immediately. Embedded live SDK engineers for rapid customization? Yes, on demand and ready to go. So are you feeling ready for a transformational freedom? Then visit vibus.com or scan the QR code to book a one-on-one with me. And in just 15 minutes, let's onboard your MSP for a game-changing POC. Stop reselling someone else's vision. Forge your legacy with Vibus. See you soon.
And what is the most exciting thing about Wi-Fi 8 that you think?
So my expectation is that you'll see those reliability in Wi-Fi 8 generation, you'll see those reliability enhancements coming out. But in addition, remember in Wi-Fi 7 or with 11BE, we added a lot of multi-link support. That has only been lightly adopted in the industry at the moment. So at the moment, what you see on the client side are mostly what's called single radio clients, where they use multi-link, but they switch rapidly between the channels. In the Wi-Fi 8 timeframe, you should see more dual radio clients. So you'll see, so the throughput enhancement in the Wi-Fi generation will primarily come from more implementation supporting dual radio, plus all these reliability enhancements that we're talking about with BN.
Okay, and just to be clear, Wi-Fi 8 will be finalized when or estimated?
So our initial draft, we expect products in the marketplace around the 2027 timeframe. So Wi-Fi 8 products, you'll start to see early products appearing in the market around the 2027 timeframe. So it's a slow process. So we go through our balloting, which will take at least a year or so within the working group. Then we go to another phase where we ballot the draft outside of our working group. In the meantime, in parallel, the Wi-Fi Alliance will be working on a certification program for Wi-Fi 8. And along the way, there will be a lot of back and forth and negotiations and input from customers and so forth on what the actual feature set will be in the Wi-Fi 8 program.
Yeah, as it is the custom. Let's move on to your AI-driven initiatives. Obviously, AI, ML, today, equipment vendors on the Wi-Fi side now really are working very hard to differentiate and create their own engines and secret sauce around AI, ML. What are the initiatives at the IEEE level or at your working group levels?
We have a standing committee. So a standing committee is a long-term group that looks into this topic called the AIML Standing Committee in .11. They generate a report on AI uses for Wi-Fi and identify areas for standardization as well. To date, there isn't much that we need. There isn't much demand for standardization around AI. I mean, the areas that are interesting are, for example, in beamforming, if you want to reduce the amount of overhead associated with sending the channel state feedback between the devices. And you can use AI to do that. But in terms of what we need to add to the standard, there's not much we need to add to the standard. The standard already supports that. It's just a matter of implementing those algorithms. Those algorithms will be implemented in specific products. And sort of similar things around traffic shaping, traffic policing, scheduling, all these things, AI could help with the performance, but there's not a lot we need to do from a standardization perspective. One area we are looking into standardizing is the interface. So the over-the-air interface, the protocols that we have today can support AI. There's not much we need to do there, but we are looking into the interface, the software interface between the wireless node and the upper layers of the software stack to support AI in a more standardized manner. So we're looking into that and what's feasible in that area.
Okay. It seems exciting. So we'll do a follow-up on that for sure. Mm-hmm. Now, one of the main themes at the Wireless Global Congress 2 weeks ago was, the convergence, right, between Wi-Fi and cellular. So I was wondering what the IEEE is doing vis-a-vis 3GPP and other organizations regarding interoperability and, what are the outcomes of those partnerships?
Yeah. So, historically, there's been some animosity between the wireless LAN group and the cellular groups, fighting with each other for spectrum, fighting with each other for dominance in the various environments. And I think that's largely played out now. I think now there's a recognition, I think, in the industry that, Wi-Fi is not going to take over outdoor operation, and cellular is not going to take over indoor operation. Wi-Fi is always going to be part of indoor service, and cellular is certainly the dominant, is the way to go for outdoor operation. So we have in the past, and we are continuing to work closely with 3GPP on improving the infrastructure, the wireless infrastructure inside buildings and outside buildings. I think it gets better each generation. It was very poor in the early generations with 5G. 3GPP added their untrusted mode of operations, where they added a security layer, a tunneling security layer over Wi-Fi. We've seen some problems with that. The overhead associated with that tunneling is not really scalable. So we're expecting that in the 6th generation, we'll have that simplified, the back-end infrastructure simplified, and we'll have tighter integration between Wi-Fi and cellular. From our side, from the .11 side, we are looking at 3GPP and the kind of, the protocols and stuff that they run over their back-end, their quality of service protocols and so forth, and adding equivalent support on the .11 side for those mechanisms.
Okay, so you're a bit more optimistic today than you were years back in terms of
every generation. As I say, the situation improves, the integration gets better. There's definitely a lot. I would say that the big operators in the world today have huge Wi-Fi networks. They support huge Wi-Fi networks, and they are interested in better interoperability between the 3GPP standards and the .11 standard.
Okay, that's probably a very good segue for my next and last question, which is, what do you say to those critics that always label Wi-Fi as being less secure than cellular?
It's contrary to the facts. Both cellular and .11 are based on the same security protocols. They use identical security protocols. The same, they're based on the US NIST standards. Both of them are compliant with those standards. They provide equivalent levels of security over the air. Where there are differences between cellular and .11 has to do with the management domain. The operators distribute their credentials through physical SIMs or eSIMs. .11 has a much broader set of authentication support. We have, for example, in the home networks, we have pre-shared key, what we call pre-shared key support, which is based on the entering passwords on the various devices. That's a simple mechanism that's required for home use. I mean, there's not going to be anything more complicated in a home. At the enterprise level, we support the enterprise authentication mechanisms, and enterprises have various types of authentication mechanisms. We support those. .11 also supports the type of security that cellular provisions with, the equivalent of the SIM distribution. We have supported that going back since modern security was introduced into .11. So there is no difference in the level of security between Wi-Fi and cellular at a technical level. If there are any differences, it's at the management level. It's at the deployment level. Who owns the network and how they manage security on that network. If as the operators adopt Wi-Fi, they will adopt it with their level of security, and it'll work fine.
Well, I hope we can contribute to removing that myth that that I hear very often, and this doesn't seem to go away. So appreciate you contributing to that. So that would be all for today. Thank you very much, Robert, and appreciate your insights today. Thanks everyone for listening. Don't forget to subscribe and like, and until the next episode. Thank you.
Thanks, Adlane. Bye.